What if we didn't have time to watch the video this weekend?
Possible. Because you guys are supposed to catch up, so Hanoka nothing.
Wait, we're supposed to catch up?
No, that's what weekends are for. Not to relax. Series 4 blank. How many group papers? Dan, pretending to look. Saying don't even, no sense even look great. Okay, well that explains it. No 4 though.
Yeah, I understand.
I'll go likely story. So no 4. And you're gonna be gone. What next? The people, you guys go on trips. You guys supposed to make up the work before you go. You guys haven't gotten to that yet. Yeah? Oh gosh. Oh gosh. Somebody stole some of my papers. Somebody stole. Okay, you're gonna have to just read me the problem because I don't have anything there. Okay, so series 3 now. Tomorrow's quiz is on series 3 and 4 plus 1 problem on the area of the snowflake. Okay, so now we are doing series 3. Okay, 2B. Isn't this the one I started you on? I did the first 2 terms for it. Is this the long division one? Gosh. Okay, no, I'll do it. Okay, tangent is sine over cosine. This bar means divide. So you take the power series of sine, which is x minus. Do we even have the 5 power series memorized yet? Oh, don't worry, Mr. Park. Tomorrow, 8:15 I got them. Except the quiz starts at 8:30. Or is it 40? X cubed over 3 factorial plus x to the 5 over 5 factorial. And hopefully we don't need any other terms. You divide it by the power series for cosine. 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial. And hopefully we don't need it. I'm only asking for 3 terms. 1 goes into that how many times? Does this look familiar? Is this deja vu? Like I did this last week? 1 goes into that how many times? X. Then you take that and you multiply it by the divisor here. So that's x minus x cubed over 2 plus x to the 5 over 24. And then you subtract. I did this for you. Subtract. I'll give you a hint. This is 3 over 6. Here. I'll do it. I'll even write it for your viewing pleasure. So subtract. Yeah. So subtract. And negative 1/6 minus negative 3/6 is positive 2/6, which is 1/3 x cubed. Now least common denominator is 120, so this is like 5 over 120. Subtract. Negative 4 over 120, which can be reduced to negative 1 over 30. Okay, then you start the process all over again. 1 goes into that how many times? 1/3 x cubed. Multiply that times the divisor. 1/3 x cubed minus x 1/6 x to the 5th. Subtract. Make the least common denominator. This is like 5 over 30. So when you subtract, that's like 4 over 30, which can be reduced to 2/15 x to the 5th. And then 1 goes into that how many times? 2/15 x to the 5th. And there's your first 3 terms. Can you see how much extra work you would have to do if I asked you for 4 terms? That would be crazy. You guys gotta be at least be able to do 3 terms there. And when this number is a 1, come on. 1 goes into this how many times? Okay, next. 3. Okay, somebody gotta read me 3.
First 5 terms of the series expansion of 1 minus x to the minus 1.
1 minus x to the negative 1 power. Okay, now I gave you, in fact, didn't I tell you lots of different ways of doing it? Is Mr. Park, I don't know any of them. What's the first one that I say? Binomial theorem, come on, we're experts! Look, A plus B to the n. Just use the binomial theorem. Okay, what's the first term? A to the n plus n. The power of A goes down by 1, the power of B goes up by 1. Plus n minus 1 over 2 factorial. The power of A goes down by 1, the power of B goes up by 1. n minus 1, n minus 2 over 3 factorial. The power of A goes down by 1, the power of B goes up by 1. That's the binomial theorem. And then if you simplify, you get 1 plus x plus x squared. Oh look, the 3 factorials cancel out. Plus x cubed. I see a pattern! Okay, so that's doing the binomial theorem. Okay, what's the other way I told you? Long division. Now, isn't this the same thing as 1 over 1 minus x? Because to the negative 1 means. And what does this bar mean? Divide by, do we know how to do long division now? Yeah. So you think you can do long division tomorrow? Well, either long division, long multiplication, or both, that's I would suspect. Look, 1 goes into that how many times? 1. Now multiply, 1 minus x, subtract. X. 1 goes into x how many times? X, multiply, x minus x squared, subtract. X squared. 1 goes into x squared how many times? X squared. Multiply, so you get x squared minus x cubed. Subtract. X cubed. 1 goes into x cubed how many? I see a pattern! Yeah, it's the same answer. Oh. And what's the other way I told you? Was that infinite geometric series, or there's one more? Infinite geometric series. Now, what's the sum of an infinite geometric series if the absolute value of r is less than 1? You better know this tomorrow. You can't do the Coke snowflake, right? Oh yeah, just memorize what I see on the internet. What's the sum of an infinite geometric series? First term over 1 minus r. That kind of looks like it. First term over 1 minus r. Arg! So what's the first term? What's the common ratio? So that means you just keep multiplying by x. So multiply by x. Multiply by x. Multiply by x. Multiply by x. Yeah, that's the same answer. Yeah, so I showed you 3 different ways to do it. But the problem is, in order to do this last one, it has to be in the form first term over 1 minus r, right? Otherwise, it won't work. Anyway, you can bet your bippy that you're going to have to do the binomial theorem on the test, though. I know you guys don't like it, but that has to be in your tool belt if you go to BC Calculus. Well, yeah, I'm not going BC. Because in AB, you just got to know up to a plus b to the third. You just got to know a plus b. See, this is the difference between A, B, and BC. In AB, you just got to know these. BC, you got to know this. I want to go AB. Yeah, I think I told you guys, right? See, when did honors first start? Algebra 1? Yeah, the difference between honors and regular, as you go along the track, the difference gets bigger and bigger and bigger as you go. So by the time you get to BC Calculus, the difference between BC and AB is like such a wide gap already. So if you go to AB from BCH, it's like a step down, man. So the only thing that can stop you then is senioritis. No, I'm serious. Okay, number 4. For what? This looks like a potential quiz problem. For what values of x is sigma n equal 2 to infinity sigma n equal 2 to infinity of x to the n equal to 1. I don't even know where to start, Mr. Park. Well, how about like write out a few terms? If you don't know what's happening, like just like sequences, write out the first few terms. What's the first number I should plug in?
2.
Okay. X squared, plug in 3, plug in 4. Goes on forever. Yeah, but Mr. Park. Yeah, but what kind of series is this? It's geometric. There's a common ratio. What do I keep multiplying by to get the next term? So the common ratio is x, right? And how do you find the sum of an infinite geometric series? First term over 1 minus r. And I want that to be equal to 1. I think now we got algebra 1, right? So cross multiply. Make one side 0. Use the quadratic formula. So x equal negative b plus or minus the square root of b squared minus 4ac, 5, all over 2. Box that, that's the answer. Minus 1 tomorrow, but minus 2 on the test. How come? That's because in order for a geometric series to converge, what has to happen? The absolute value of r has to be less than 1. Otherwise the series diverges. So, what does this mean? This means x has to be between negative 1 and 1. So, are both of these numbers between negative 1 and 1? No, so you have to cross out the one that's not. Just look on the bottom and cross out the other one. I know how you do this. Okay, and then number 5. Does that mean all of number 5? That's okay. We don't have a lecture and we get it on video. There should be no excuses tomorrow. Okay, 5a. Sigma, no, I can say 2 to the n. Sigma, n equal 1 to infinity, 2 to the n plus, maybe I can see, 5 to the n, 5 to the negative n, all over 3 to the n. Now, if you write out the first 3 terms, it's like all haywire, right? So what you do is you massage, you lift and separate. Anyway, this is a very important skill in calculus. Whenever you see a single term in the denominator, you're going to want to lift and separate. So if I lift and separate, what do you get? 2 to the n over 3 to the n plus 5 to the negative n over 3 to the n. Now why would you want to do that? N, that's 2/3 to the n. And what happens when you have a number to the n power? That's geometric. So that's a geometric series. And then you can make separate sigmas, right? And then isn't this the same thing as 1/15 to the n? That's like 5 to the negative 1, that's why, right? Hey, that's a geometric series. This one, the common ratio is 2/3, the common ratio here is 1/15. So if it's and are both of these, is the absolute value of r less than 1? Yeah, so I could use the formula. So what's the first term here? Anyway, by the way, was it 0 or
0.
oh, thank you for telling me now. Okay, so if it starts with 0, what's the first term? Plug in 0. 1 over 1 minus r. And then what about this one? 1 over 1 minus r. And then just add those two numbers up there. That's your answer. Remember, a geometric series, number to the nth power. That's geometric. The number in the parentheses is the common ratio. Or you can just write them out and then it's going to take a long time. Okay, we got a KISS problem here. Oh, I thought we had this down. Do you think you can see a KISS problem tomorrow?
Yes.
1996, obviously that's when I wrote it. And what is it? Was it 1/2 plus root 3 over 2i? Okay, so the first thing you need to do is write it in KISS form, polar form. Okay, so draw the picture. In the complex plane, if I go 1/2 to the right and root 3 over 2 up, how far from Oregon am I? 1. Oh, Mr. Park, it's always 1. And then what's that angle? 60 degrees, which is pi over 3. You can write 60 degrees if you want. Okay, now, do you remember the other problem we did last week? What was the pattern on that one? Every 8 cancels out to 0. So that's the trick in doing this problem. You have to figure out how many will cancel out to 0. So what's the first one? plug in 1. How do you raise it to the first power?
1.
1 is pi over 3. Then you raise it to the second power. So 1 to the second is 1. And then what do I do with the angle? You multiply it by the power. So that's 2 pi over 3. And then when you plug in 3, 1 to the third is 1. Then you multiply the angle by 3. And it just keeps on going. And then we draw a picture again. Here is a unit circle in the complex plane. How do you graph this vector? Make it 1 unit long, making an angle of pi over 3. 1 unit long, 2 pi over 3. 1 unit. Do you see a pattern? Every 60 degrees there's another one. There she blows! So what have we discovered? Every 6 cancels out to 0. Every 6. That's the pattern here. So if we know every 6 cancels out to 0, how do I add up 1996 terms then? You divide it. So 1996 divided by 6 is 3 carry 1, 3 carry 1, 2 remainder 4. So there's 332 groups of 6, but they all cancel out to 0. There's 4 left over. So what are the 4 left over? You either look at the first 4 or the last 4, right? Okay, let's look at the first 4. 1, 2, 3, 4. That's your answer. You add up these 4 vectors, that's your answer. Yeah, but Mr. Park, this one and this one cancel out because they're pointing opposite ways and they have the same length. So the answer is just this one and this one, which is 1 kiss 2 pi over 3 and 1 kiss pi. And then you guys know how to change it back? Or shall we just review that since it's on the video? Okay, let's do it! What does KISS stand for again? Cosine theta plus I sine theta. Well, hopefully by now you can just do this in your head, yeah? Wishful thinking. Plus I sine pi. Okay, so this is what? Negative half, and that's plus root 3 over 2i. Cosine pi is negative 1, so plus negative 1 plus 0i. So simplify that. Your answer is negative 3 halves plus root 3 over 2i. Box that, that's the answer. Yes. So do you see the key to this problem? You have to figure out every so many cancels out to 0. You got to figure out what that number is. So we had one problem last week where it was 8, now it's 6. What do you think the next one's going to be?
12.
Every 48 cancels out to 0. I could make a problem like that. Let's go for the gusto, every 128 then. Okay, next. Oh, we gotta get, okay. If we don't get to those problems, good luck. Okay, I'll tell you right now. C through F are all the same. They're power series. If you don't have your 5 power series memorized, that's why you can't do these problems. Okay, pick one. I'll just do one because they're all power series.
D.
Okay, D then. Okay, read it to me. Sigma n equals 0 to infinity negative 1 to the
n
Pi
to n plus 1
pi to the n plus 1?
to n plus 1 over
2n plus 1 factorial.
yeah.
Okay. All I can tell you, write out the first few terms. Plug in 0, 1, 2, 3 and see what you get. Okay, plug in 0. We cannot even plug in 0. What pair do we have for 1? Pi. Just pi then, right?
Yeah.
Plug in 0. Plug in 1 now. Negative pi cubed over 3 factorial. Plug in 2 now. Plus pi to the 5 over 5 factorial. Plug in 3. Pi to the 7 over 7 factorial. Okay, there you go. That's good enough. Hey, you want power series, huh? You stay with power series. Which power series has the odd numbers factorial in the denominator? Sine. So here, sine box is equal to what? Box minus box cubed over 3 factorial. This one's easy. Minus box to the 7 over 7 factorial plus da da da. What number do I put in the box to get these numbers right here? Yeah, pi. See, if I put pi in the box, that's this. So the answer is just sine pi, which is 0. So if you keep on adding these numbers forever, you get 0, which is good. What's the purpose, yeah? What's the sense? Oh, why do I want to add an infinite number of things and get 0 as my answer? Because you can. So all of those problems at the end, you do exactly what you did. You write out the terms and they go, hey, you want power series. But then that only works if you know the 5 power series. Don't worry, Mr. Park, I'm going to memorize them by tomorrow. Yeah, but you memorize them wrong tomorrow. And you got to know these power series till you finish BC calculus. Oh yeah, another pink BC. Series 4. Okay, number 1. Okay, 1, 2, 3, and 4 are all the same problem. And number 5, you should be ashamed of yourself. I told you what the problem is. Maybe tomorrow we need an ultra maxi quiz instead of a regular quiz.
Here's the 1 and 4, not 3.
Well, I'll do 1, 2, 3, or 4. Because they're all the same. You could, did you guys read the notes like I told you to do? Did you read Leibniz's theorem? Everybody take out your notes. I want you to read it right now. No wonder you can't do problems 1 through 4 because you haven't read Leibniz's theorem. Those deal with Leibniz's theorem. Read it silently. Silently! Okay, do we understand Leibniz's theorem?
Yes.
Okay, first of all, oh, we do.
What is the brackets thing around A and?
That just means it's a series. I mean, a sequence. That's just this, you know, this part. This is the A sub n part there, without the sigma. Without the sigma. So in order for Leibniz's theorem to apply, this thing has to go to 0. In other words, the terms, the individual terms have to get closer and closer to 0. And it has to be alternating. It has to go positive, negative, positive, negative. Or you mean like the Coke snowflake one? No, the Coke snowflake one wasn't alternating. Never mind. Okay, now, here, let me demonstrate Leibniz's theorem with this one. Can I apply Leibniz's theorem to this series right here?
Yeah.
Yes, because the terms are getting smaller and smaller, and they're alternating. So here, this is what Leibniz's theorem says. If I add up, let's just say I use 3 terms. If I just add the first 3 terms of this power series, do I get the actual, the exact value of sine pi? No, you have to add forever. Okay, but how close will I be to the actual answer? What is my magnitude of error? Well, what does Leibniz's theorem say?
What's the
It's this, the first term that you didn't use. So if you add the first 3 terms up, how close will I be to the actual answer? Within this, the first term that you didn't use. That's what Leibniz's theorem says. You get it? Okay, so let's see how we can apply this to a problem. So now, what do you want to do? 1, 2, 3. I'll pick it then. Let's do number 3, because that looks fun. That looks like the one we can see tomorrow. Using the power series for a natural log 1 plus x. Okay, so the first step is you got to know the power series. Let me just test somebody at random. Yoshina. Okay, Yip, because she's not going to be here, and she has her all memorized already.
Like 1 plus
No.
1 minus x squared over 2.
No.
Just kidding.
No. Starts with x.
minus?
People, if you don't know the 5 power series, you have no prayer in this chapter. Don't worry, tomorrow I'm going to have it. Minus x squared over 2 plus x cubed over 3 minus x to the 4 over 4. Is that right? Or is there factorials on the bottom?
No, it's right. You have to teach you.
course it's right. Okay, now it says, number 3, how many terms are needed to approximate natural log of 1.2? Okay, now, if you want natural log of 1.2, what number do I have to plug in for x? 0.2. You get it? Because 1 plus 0.2 is 1.2. But I'm telling you, if you don't have a calculator, you want to work with fractions. So 1/5 is 0.2. So all you have to do to get natural log of 1.2 is plug in 1/5 for x. Okay? So plug in 1/5 for x. Now, we want the magnitude of error to be less than what? 10 to the negative 6. That's 1/1,000,000 then. So we want to find the first term that's smaller than 1/1,000,000. And then you just use all the terms before that because that's going to be the magnitude of error. So you just got to keep writing out terms and ask yourself, okay, obviously that's not less than 1/1,000,000. What about this? Is that less than 1/1,000,000?
No.
No, that's, if you simplify that, what is that? 1/50, that's not smaller than 1/1,000,000. Okay, what about the next one? 1/5 cubed over 3. That's 1/125, so 1/375. Are you my mother?
No.
No, so you go to the next one. 1/5 to the 4th over 4. So that's 625.
No.
Well, you gotta know the number. Silence, I'm trying to think. 625 times 4, 2,500.
No.
Are you my mother? Then you go to the next one. So you just gotta keep on going until you get a number smaller than 1/1,000,000. That's what you gotta do. Oh no.
So you have to do all that math without a calculator?
Yes! Or you just figure it out. You don't have to get the exact number, but you gotta know if it's smaller than 1/1,000,000. Okay, so that's 5 to the 6th power. Whoa. So that's like 625 times 25. Ooh, let's just do this for fun. 5 carry 2, 3, 1, 0, 5, 1, 2, 5, 2, 6, 5, 1. So 15,625. Are you my mother? No. So we gotta go to the next one. Okay. Oh, but then look, this is 5 to the 6th, and then you gotta multiply it by 6. So you just multiply this number by 6. That's easy. 0 carry 3, 5, 3, 3, 3, 9. 93,750. So 1/93,750. Are you my mother? No, so you go again. 1/5 to the 7. Okay, no, don't do it then. Over 7. Oh gosh. Okay, so what would that be? That would be like 1/5 to the 6 times by 35, yeah?
Oh.
So isn't this 1/5, this is like 5 to the 6th power. We gotta multiply this by 35. Right, you see that? Because then you got an extra 5 and a 7, right? So times it by 35. Why, is this too ridiculous for you? Okay, what if I let you use a calculator then? Hurry up, we only got 5 minutes left and we're gonna talk about this problem. Quick, somebody do this on the calculator. Don't worry, tomorrow I'm not gonna give you 10 to the negative 6. What if I give you 10 to the negative 3 then? Can you handle that?
Yeah.
Like, okay, what if we did, okay, let's just say tomorrow, it's at 10 to the negative 3. What you do is you look for the first number that's smaller than 1/1,000. Are you my mother?
No.
Are you my mother?
No.
Are you my mother? Yes! That's the first term that's smaller than 1/1,000. So therefore, if you add up the first 3, you will be within 1/1000th of the actual answer. That's what Leibniz's theorem is saying. Actually, Leibniz's theorem says you will be within this of the actual answer. But this is smaller than 1/1000, so therefore, you know what I'm talking about? You will be within 1/1000 of the actual answer. Anyway, what is this? Is this, are you my mother on the calculator? So 1 more. Minus 1 to the 5th over, to the 8th over 8. Are you my mother? Somebody do that on your calculator. Is that smaller than 1/1,000,000? Gotta rely on Chai again. Everybody get iPad. I don't want to pull out the pocket cast. Are you my mother? Yes! So, this is the first number that's less than 1/1,000,000. Add all the ones before it. So if you add these first 7 terms, you will be within 1/1,000,000th of the actual answer. That's how Leibniz's theorem works. Now do we understand Leibniz's theorem? Okay, yes, without a calculator, I'm not gonna make you do 1/1,000,000. Or will I?
Where's Leibniz in the?
Leibniz, two people invented calculus, Sir Isaac Newton and Gottfried von Leibniz. Leibniz would probably be in the top 20. Okay. Okay, 5 and 9. Okay, we're gonna just save 9 already because this is it. Okay, number 5. This problem's on tomorrow's quiz. Okay. I did y equal x squared for you last week. Woo! Woo! Okay, y equal x cubed. From where to where? 0 to what?
1.
Okay, 1. So, didn't last week I go y equal x squared from 0 to 1 and then we change it to x cubed, all hell breaks loose. Okay, so here we go. If 0 to 1 is 1 unit long, right? 1 unit.
Yes.
Okay, so if you break that up into n equal parts, each part's going to be 1 over n, then 2 over n, 3 over n, and then how should I write 1? N over n. Okay, then you use the right endpoint to cap off the rectangles like this. You do. Okay, what's the area of the first rectangle? Base times height. 1 over n times, what's the height of this first rectangle? Isn't it the y coordinate at that point? Which is 1 over n cubed, right? If you know the x coordinate, you just plug it in there to find the y coordinate. Okay, next rectangle, what's the base? 1 over n, and the height will be the y coordinate at that point, which is 2 over n cubed. This is exactly the same thing I did last week, except there's a cube there instead of a square. That makes all the difference in the world, Mr. Park. What's that? 1 over n. And then the height is 3 over n cubed. And you just keep on going until you hit the last rectangle. What's the base? 1 over n. And the height of the rectangle? N over n cubed. Okay, now we simplify. What can I factor out? 1 over n to the 4th. What's going to be left? 1 cubed plus 2 cubed plus 3 cubed plus ... plus n cubed. Hey, you somebody! Anyway, the only way you can do this problem is the thing in the parentheses here has to be somebody. If it's not somebody, you cannot do it. And what is the somebody? Hey, I know you. N times n plus 1 all over 2 squared. And then this is the formula for the sum of the areas of n rectangles. So if we want to find the area exactly, we take the limit as the number of rectangles goes to infinity. And do we know how to find this limit? If the degree of the top is the same as the bottom, you look at the coefficients. 1 all. If I were to multiply out the top, what's the first term going to be? N to the 4th, right?
Yeah.
If I multiply at the bottom, you get 4n to the 4th. So what's the coefficients? 1 over 4. So the area here, this area, is exactly 1/4 square unit. Exactly. This is the beginning of calculus, people. I don't like it. I'm just gonna take, what are you guys gonna take, AP Stats instead? Man, but there's a lot of writing. You gotta write paragraphs, you know, in AP Stats. That's what it is, though. You have to interpret data. They give you a problem, and then you gotta explain why a certain thing is. Okay, so tomorrow's quiz, 5 problems. One of them, find the area of the Coke snowflake. Jack, you want me to just tell you the answer? No, you can look it up online. You gotta show me how you get that answer. Just do it like the way I showed you on the board. I showed you what to do. You write out the first few terms, and then you go, hey, do geometric. Do geometric, man. Yeah. What? I don't know, man. You tell me. Okay. No! very beginning. Oh!